Hello, let's go over the Unit 12-13 study guide. So number 1, it asks which 3 shapes are quadrilaterals. Quadrilaterals are 4-sided shapes that have all straight lines. Okay, so A only has 3 sides. It is not a quadrilateral. B does have 4 sides. They are all straight, so it is indeed a quadrilateral. This is also considered a square, parallelogram, a rectangle, a rhombus, many things. C has 1, 2, 3, 4, 5, 6, so it is not a quadrilateral. D has 4 sides. All sides are straight, so it is indeed a quadrilateral. E is the same. 4 sides, all are straight. F has 5 sides, so it is not a quadrilateral. We have selected B, D, and E. That is 3, so we have completed that problem. Number 2, it's kind of hard to see the boxes here. You can draw them in. You can just put an X under it. Either way is fine. It says for each shape pictured in the table, select the box for each correct shape name. You may select more than one box for each shape. If the shape is not a rectangle, rhombus, or quadrilateral, select the box for none of these. So the thing about rectangles, they have 2 pair of congruent and parallel sides with 4 right angles. A rhombus has 4 congruent sides, 2 pair of congruent angles. A quadrilateral, we know, just means that it has 4 sides that are all straight, and none of these would be none of these. So a shape 1, it does have 2 pair of congruent sides. All angles are right angles, so it is indeed a rectangle. This has 5 sides. The second one has 5 sides, so it is not a quadrilateral, which means it cannot be a rectangle or a rhombus, so it's going to be none of these. The first one is also a quadrilateral. I apologize. Here we have shape 3, and it does have 2 pair of congruent sides. In fact, all sides are congruent, and it does have 4 right angles. So that means it is a rectangle, a rhombus, and a quadrilateral. This is a square, and kids have learned that a square is many things. Okay, here we have a trapezoid. It has 1 pair of parallel sides. It has 1 set of congruent sides, but it does not have 2 pair of congruent parallel sides or 4 right angles, so it cannot be a rectangle. It does not have 4 congruent sides, so it is not a rhombus, but it is a quadrilateral because it has 4 sides. On number 2, it has 2 pair of congruent and parallel sides, but it does not have 4 right angles, so it is not a rectangle. But it does have 4 congruent sides, so it is a rhombus, and it is also a quadrilateral because it has 4 sides. Okay, number 3. Which words describe this shape? Choose all that apply. And we've talked about what a rhombus is. A square is a 4-sided shape, aka a quadrilateral, that has 4 congruent sides and 4 right angles. So there we go. Quadrilateral has 4 sides, and a parallelogram is a shape that has parallel sides. So this is in fact a rhombus. It meets that criteria. It is a square. It is a quadrilateral, and it is also a parallelogram. Squares are really cool. Squares are super cool. Okay. Robin told Mary that she drew a quadrilateral with angles all the same size. Okay, the only way you can have angles where all are the same size means they are going to have to be right angles. Robin said the shape must be a square. Is Robin correct? Well, if a quadrilateral has 4 right angles, it could be a square, but it could also be a rectangle. So we're going to say that no. The answer is not yes. So now we have to look at B and C. No, it could be a rectangle. No, it could be a triangle. Well, the only one that would actually be a quadrilateral would be a rectangle, so B is our correct answer. Okay. Number 5. This one's a little complicated whenever printed out on paper, so it sounds a lot harder than it is. Real quick, just as a reference, we have perpendicular lines, and we know that perpendicular make a perfect square, talking about the angles, perfect right angles. And then you have parallel, which we know have a pair of parallel lines in the word. Okay, Malcolm draws this map of his neighborhood. Fill in the blank to complete the statement about Malcolm's map. Beach and something are some type of street because they cross each other at a right angle. So beach and what would cross at a right angle? Well, a right angle would be perpendicular. And the street that is perpendicular to Beach Street is Alden Street. Okay, beach and something are something because they are the same distance apart and do not cross each other. So they run side by side but never touch. We know that means parallel. And what runs parallel to Beach Street would be Elm Street. Okay, not too bad. Just gotta pay attention to what we're thinking about. Okay, so here on the study guide, you are not able to drag and drop, obviously. So we can just write next to the angle what it's gonna be. So it says, identify whether each angle is acute, obtuse, or a right angle. Okay? So acute, we think, oh, it's such a cute little angle. And that means it is less than 90 degrees. And obtuse, we think of an obese angle, and that's going to be greater than 90 degrees. And a right angle is just right. It makes a perfect square, and we know that that is exactly 90 degrees. Okay? So we also know that on a right angle, it can be represented with a little square. So here we do know that this is a 90-degree angle. So we know that that is called a right angle. Okay, 60 is less than 90, so that's going to be an acute angle. 45 is also less than 90, so it's going to be an acute angle. Also, I wrote these backwards, the symbols, less than 90, greater than 90, I apologize. Here we have a angle that is above 90 degrees, it's greater than 90, so it's going to be an obtuse angle. 135 is also bigger than 90, so it is an obtuse angle. Not too bad. Again, acute means it's less than 90 degrees, obtuse means it's bigger than 90 degrees, and a right angle means it's exactly 90 degrees. Okay, so here we go back to talking about parallel, perpendicular, or neither. So let's look at them. Okay, so we have a pair of lines right here. They make a perfect square, so we know that they are perpendicular. Here, they run next to each other, but they never touch. And so those are parallel. These touch, but they do not make a right angle, so these are going to be neither. They're actually called intersecting lines, which we've talked about a little bit. but we don't have to be able to specifically identify those, that they're called intersecting lines. Here, these run next to each other but never touch, so they are called parallel. And again, these touch, but they do not make a 90-degree angle, so they are not going to be perpendicular. They are going to be neither because they are intersecting lines. All right. So Hannah, Hannah gets a juice box like the one shown, this one, when she buys a lunch. Which measurement is closest to the amount of juice in a full juice box? Well, I'm going to talk you through the way that we discussed this. Okay, so we said that if it's 1 or 2 millimeters, this is like drops of water. Okay, technically 250 milliliters is about the size of a milk carton. 2 liters is a big bottle of soda, or 2 Stanleys full of water. And 200 liters, that's about the size or about amount of water that you would need to fill a tub of water, like a bathtub of water. So whenever you look at this little thing of juice, that is going to mostly resemble a milk carton, so we're going to go with 200 milliliters. That is the most reasonable answer. Okay, number 9. Gwen pours about 3 liters of water into a container. Which arrow shows about how much water Gwen poured into the container? Okay, so if we look, here is 3 liters. So I'm going to just darken that line, 3 liters. And so we're going to look and see which arrow is the closest to that 3 liters. So arrow 1 goes quite a bit above it, but arrow 2 is very close, right at that 3 liter mark. So we're going to color in arrow 2. That keyword there is about, and that means it's not going to be exact. All right, number 10. We're getting into a lot of time. All right. Anna starts eating lunch at 12:15 p.m. She finishes eating lunch 40 minutes later. Which clock shows the time that Anna finishes eating lunch? Well, so this is going to be an elapsed time problem as well as a reading a clock problem. So what we've done in class is we've actually made sure that we write the start, end, and elapsed for every elapsed time problem. That way we can label what part we know and we can figure out what part we're actually looking for. So she starts at 12:15 p.m. We don't know what time she ends, but we do know that it's 40 minutes later, so that's 40 minutes have elapsed. Okay, so let's use a number line or a timeline to help us figure this out. We start by marking where our start time is, that's 12:15, and then you can go whatever increment you want. On this number line, we've focused really heavily on using 10s, 5s, and 1s. So let's go on and do 10 minutes. I've recommended that kids keep a running tally over here of how much time they've gone so that they don't mess up on that regard. So 10 minutes after 12:15 would be 12:25. We have 30 minutes left. We're going to go another 10. That's going to be 20 minutes. Go that 10 minutes. We're going to have 12:35. 10 more minutes is 12:45. And now let's go our last 10 minutes. And that's going to be 12:55 p.m. So now we're going to look for a clock that shows 12:55 p.m. Well, we know that A goes past 1 o'clock, so we know that that's not correct. Here we have, it's in the 12 o'clock hour. We count by 5s, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55. So that could be the correct answer. It is, in fact, the correct answer. But if you would like to continue the practice on reading a clock, we know that this one is in the 12 o'clock hour still. And then we count by fives. We go 5, 10, 15, 20, 25, 30, 35, 40, 45, 12, 45. And here we know that it's exactly 1 o'clock. So just as an option of practicing that reading time and telling time. But the answer is indeed B. Okay, next up. Okay, so number 11. It simply asks what time is shown on the clock. And so let's look at our hour hand. It's between 10 and 11. That means it is the 10 o'clock hour. And now we're going to count by 5 starting at 12 until we get to the nearest 5 mark. So we go 5, 10, 15, 20, 25, 30, 35. And now we count by ones. So 35, 36, 37. And we know that C does match that, so C is our correct answer. 12, same thing. We're going to look at our hour. It's between 8 and 9, so that means it's the 8 o'clock hour. And let's count by fives. 5, 10, 15, 20, 21, 22, 23. So it is, in fact, 8:23. Not too bad, not too hard. Important life skill. So now we have another elapsed time. So it says Josh finished washing his dog at 3:05 p.m. The time he started washing his dog is shown. How many minutes did Josh spend washing his dog? So just like we do anytime we have a elapsed time problem, we start out by labeling what we have. Start, end, and elapsed. Okay, so the start time, it tells us, is 2:40 p.m. and the end time is 3:05 p.m., which means that we're trying to find the elapsed time. You can do that on a number line as well, or a timeline. We label our start and end. So our start is 2:40 and our end is 3:05. I recommend kids go in 10s, 5s, and then 1s. Just that helps them if we end in a 10. So we're going to go 10 minutes, and that's going to be 2:50. We're going to go 10 more minutes. That's going to be 3 o'clock. Can't go 10 more, so we're just going to hop on over here with 5 more minutes, and that's going to give us 3:05. Now we add all of these up. We have 10, 10, 5. 10 plus 10 plus 5 is, in fact, 25. So our answer is 25 minutes. If your kids want to use a different strategy, as long as it makes sense to them, I don't mind them doing that. This is just the most simple way that I've seen to really make it make sense in your brain. Number 14. Aiden read for 20 minutes. The clock shows the time he stopped reading. What time did he start reading? So let's label these as start, end, elapsed. Okay, so we're looking, it specifically tells us that we're going to be looking for what time it started. So we're going to leave that part blank for the moment. His end time is shown here. And so we know that that's 4, 5, 10. So 4:10. And that he read for 20 minutes. Okay. Again, we can use a number line or a timeline for this. All right, so we don't have the start time, but we do have the end time, and that's 4:10, and we need to go back 20 minutes. Okay, so let's go back 2 sets of 10. So back 10 minutes is going to be at 4 o'clock, and back 10 more minutes is going to be 3:50. So our answer is, in fact, 3:50, which is C. That's what time he started reading. All right, one more elapsed time. Lee left to go to the mall at 4:27 p.m. He arrived at 5:08 p.m. How long did it take Lee to get to the mall? So many minutes. So again, we need to label this as start, end, and elapsed. Okay, so we know that he left at 4:27 p.m. and he arrived at 5:08 p.m. And we're trying to find that elapsed timer there. So again, number line, put our start and our end. So we have 4:27, 5:08. Now I recommend that kids get it to a 10 because that's going to make it easier for them to actually move. So to get to the nearest 10, to get to 4:30, we need to go 3 minutes. And then you could very easily go by 10 or even by 30 if you really wanted to, up to 5:08. So we're going to go 10 to get to 4:40. 10 more minutes to get to 4:50. 10 more minutes to get to 5 o'clock. Okay. And then we need to go 8 minutes to get to 5:08. So we're going to write that. Now you just add them all together. So we're going to add 10 plus 10, 3 plus 10 plus 10 plus 10 plus 8. So 3 plus 8 is 11. We write our 1, regroup our 1, and now we can count them 1, 2, 3, 4. So it did take 41 minutes, and that's what they would just need to type in, the 41. Nothing major there. All right, so number 16, it's on 2 pages. You're going to use this to reference the graph. It says the table shows the number of times Maria did each activity during summer vacation. We have went camping, visited an amusement park, saw a movie, and slept over with friends. And so this is a 2-part question. Part A asks us to just choose the graph that actually shows that information. So I'm going to look right here. I think it's on the back of your paper. And we're going to look. I suggest starting with went camping and seeing if that's at 12. So this shows right here. It's halfway between 11 and 13, which means that it could be 12. Here it shows going above 13, so that's not going to be a correct answer. This is way above 12, not a correct answer. D shows right at 11, so that also is not the correct answer. So A is the only one that's showing that it could be correct, but let's verify. So it then says that he went to the amusement park 6 times, or she went to the amusement park 6 times, and so that does show 6. That she saw a movie 18 times. Oops, I got off the line here. And that she slept over with friends 21 times. So all of that information is correct. Therefore, it is the correct answer. Okay. Now, it asks another question about this information, and you're going to have to actually look back at the table or at the graph to answer this part. And it says, how many more times did Maria see a movie than go camping? So how many times did she see a movie? 18 times. How many times did she go camping? 12. And with asking how many more, that's asking us to find the difference. And when you find the difference, that means you subtract. So we're going to do 18 minus 12, which does equal 6. And their answer would just be 6. Not too bad. Okay. 17. 2 more problems. Look at the following pictograph. We have Rob, Coleman, and Neville. Each full cookie represents 2 boxes of cookies, and each half cookie is equal to 1 box of cookies. So here we know that this Rob has 1, and we can count by 2's here. We say 2, 4, 6, 8, 10, 12, 14, 16. Neville is 2, 4, plus 1 more is 5. That's an easier way to see that information. So it asks, how many boxes of cookies did Neville sell? So we're only going to be looking at Neville, which means our answer is 5. We have 2 boxes, or 2 complete cookies, which means 2, 4, plus 1 half right here equals 1 box. So that's 4 plus 1 equals 5. So he had 5 boxes of candy. Okay. Here is our last question. It says, this bar graph represents the number of students with different colors different hair colors at school. All right, and it says select the 2 statements that are true about this bar graph. Okay, so let's go ahead and label what our data is here. So it's saying that red is probably at about 6 or 7. Black is going to be probably around 27. This is not asking for completely accurate. Here we're probably at about 34 for brown. And blonde is probably going to have about 21, 22. Okay, so remember, we're selecting 2 statements that are true from this bar graph. There are more people with blonde or red hair combined than those with brown hair. So let's see. If there are, let's say, 22 blonde plus 7 red would equal 29. Would that be close to brown's 34 to being a higher number? No, so we know that that is incorrect. There are about 16 more people with brown hair than black hair. Okay, so let's say 34 minus 27, because there's about 34 brown and about 27 black. So 4 minus 7, I can't do that. I go over here, make this a 2, make this a 14. 14 minus 7 is 7. 2 minus 2 is 0, so the answer is 7. That's nowhere near 16. Could not be a correct answer. There are approximately 90 students at the school. Well, to know that, we need to add them all together. So let's line these up, stack them where they are on top of each other by their place value. So we have 7, 27, 34, and 22. So if we say 7 plus 7 is 14, 14 plus 4 is 18, 18 plus 2 is 20, so I'm going to write my 0 and carry my 2. 2 plus 3 is 5, 5 plus 2 is 7, 7 plus 2 is 9, so that is about 90. That could be a correct answer, so I'm going to put a little question mark until we determine which others could be correct. There are less people with red hair than any other hair color. Well, if I look at red, it is the smallest by far on the graph, so that's probably going to be a correct answer. It could be. And then it says there are about 40 people with red or blonde hair. Well, we could add that again, but we did add that up earlier to know that that was 29, so we know that that's not a correct answer. The question asks us to find 2 statements that are true. We do have 2 that we marked as possible correct answers, so we don't have to go any further. We can mark those as our correct ones, and we are all done. If you have any questions, please reach out, and I have no problem helping. Have a great day.